Hello everyone, welcome to chemistry class. This is the chapter number 3 that we begin today, acids, bases and salts. In this chapter we will be learning the topics and concepts related to acids, bases and salts. In this present class, that is the first class for this chapter 3, we will begin the chapter with acids and we will learn the different types of acids and how acids are prepared. In chemistry we are learning about different elements and those elements as a result combine together to give compounds. The different kinds of compounds all around us can be then further classified into acids, bases and salts. In the lower classes you have been learning this. The acids are the ones having sour taste, the bases are having bitter taste and they are soapy to touch. And when acids and bases combine together, they give us salt. This is all some basic information. Let us begin our today's topic, that is acids. Although in the introduction part the definition for acid, base and salts are given, I have skipped them because individual definitions we will be covering in the topic one by one. So today we will see now what is acids. Here the definition, let us have a look here. So acids are what? They are the compounds which contain one or more hydrogen atoms when dissolved in water. Yes, you have to remember hydrogen atoms. Always whenever any acid is dissolved in water, it will give us hydrogen ion. That is, it will give us H plus ion. Always it will give us H plus ion. This is the concept regarding acids. All the acids are sour in taste. Different acids are sour in taste. Here the table is given for us. These acids are naturally occurring one along with the acid name. These are the acid names given here, and on the right side here we are given the source where these acids are present. So this is what all are naturally occurring acids. So different acids are having sour taste, and whenever these acids are dissolved in water, they will give us what? They will give us H plus ion. In turn, let us have a look at the example given here. For example, HCl is an acid here, and when it is dissolved in water, it dissociates into two different ions. In the last chapter, previous one, also we have seen this, the polar compounds. This HCl is a polar compound. So when it will dissociate into two ions, they will be H plus and another one will be Cl minus. So these are the two ions. So we have to take care of this H plus only. So H plus is given whenever any acid is dissolved in water. We will get this H plus ion. In turn, this H plus ion which is produced when acid is dissolved in water, this H plus is not a stable ion. It is not a stable one. So what it will do, it cannot remain independent, and as a result it combines with the water molecule. In that water in which we have dissolved the acid, in that water molecules which are present there, this H plus ion will dissolve. So as a result H plus will combine with the water, and what we will get, that is H3O plus, that is hydronium ion. The formation we have seen already in the previous chapter. So that is hydronium ion is formed. So indirectly what is forming? Indirectly we can say acid on dissolving in water, it gives us what? It gives us hydronium ion, that is H3O positive ion is produced whenever any acid is dissolved in water. So two concepts you have to remember. One is acids contain what? Acids always, each and every acid will contain hydrogen atom. Acid contain hydrogen atom, and what they produce on mixing in water is H plus ion, which in turn gives us hydronium H3O positive ion. So here the point is given, what I told, hydrogen is common in all acids. So one example you have seen, HCl being an acid and how it dissociates into ions. Many more examples of acids are there. One by one we will have a look on them. Let us have the look on these equations given in this downside part here of this page 38. You can refer to your textbook as well. So H2SO4 here as well, same thing is happening. H2SO4 combines with water, and what we are getting, you can see here both H3O, that is hydronium ion, is common in all three equations. Second equation being with HNO3, the last one is CS3COOH, that is acetic acid. All different are acids only. The first one now, H2SO4, that is sulfuric acid. Sulfuric acid, when it is dissolved in water, what will produce there is, its hydrogen atom, its hydrogen will form H plus, and that H plus will combine with water molecule. As a result, we will get H3O positive, H3O positive. And what is remaining here of that sulfuric acid is SO4. SO4 means sulfate, and sulfate is a negative radical, that is SO4 2 minus. So what we will get in remaining part is SO4 2 minus ion will remain. One part is H3O positive, that is positive ion. Another one is SO4 2 minus. So that is how the equation is formed here. Second one also you can see HNO3. This HNO3 is also broken into two parts. One is H plus, another one is HNO3. When nitric acid, HNO3 is dissolved in water, both the part dissociate. This H plus combines with water in which we have mixed the acid, and we will get H3O positive, and the remaining negative radical remains as such. The last one also CH3COOH. This is acetic acid. In this also one part is negative, CH3COO. This is the negative part, and the remaining one, that is H, remains positive. So acetic acid dissociate into two parts. This CH3COOH, out of this H comes out to be H positive, and then it will give us hydronium ion. This is happening with all the acids. They all produce hydrogen ion, which in turn give us hydronium ion. Having been discussed about the acids, the definition you have to learn here: the compound which contain one or more hydrogen atom, and when dissolved in water they will produce hydronium ion. Those kind of compounds are called as acids. Having been learned about the acids, now we will have a look on the classification of acids. Acids can be classified into different ways. The first method of the classification is depending on the sources from where we are getting these acids. So there are two primary sources. One is the naturally occurring acids. The naturally occurring acids, generally in the plant sources, they are found from the plant sources. So those kind of acids are called as organic acids. The another category is of inorganic acids. Inorganic are the ones which we are generally getting from the earth crust. From the earth crust we are getting the inorganic acids, and these inorganic acids are also referred to as mineral acids. They are also called mineral acid. The inorganic ones are called. Organic examples here in this table, you can see here all these are organic ones because these are all naturally occurring. For example, vinegar, it is called acetic acid, commonly known as vinegar. All the different citrus fruits like oranges, lemons, grapes, etc., all are having different acids. Here you can see grapes are having tartaric acid, tamarind, apples, all are having different acids. Different fruits are having different kinds of acid. One important one you can see here, think of bees and ants. In different insects, when they are biting us, actually they are releasing formic acid. So all these are the different acids, and these all are organic acids. Next one, the inorganic acids. They are usually obtained from the minerals, from the earth crust. In the different forms, many minerals are extracted from the earth crust, and they are all producing what are known as inorganic acid. Example, HCl. Another example, H2SO4, that is sulfuric acid. Another one we can write HNO3, that is nitric acid. Many more we can write like H3PO4. Then we have H2CO3, that is carbonic acid. So it must be simple now. Organic acids are the ones obtained from natural sources. Examples: oxalic acid, acetic acid, malic acid, anyone you can name. The another one, inorganic acids, are also known as mineral acid, and because they are obtained from the minerals, or we can say they are the ones obtained from the earth crust. Example, HCl, sulfuric acid, nitric acid, and so on. So the minerals are obtained from the earth crust, that is why they are mineral acids. So now, apart from this, there is an important part of these acids, that is the organic acids are called as weak acids. On the other hand, the inorganic acids are called as strong acids. Now what is the difference between weak acids and strong acids? So the first one, the weak acids. The weak acids are the acids which do not ionize. Ionization means the single acid compound will form different ions, positive and negative ions, whenever they are dissolved in water. So if we are dissolving any weak acid in water, they will not ionize completely. They will ionize, but that ionization will be partial. They will not ionize completely. So that is For example, we will have a look here. For example, you can take one acid, acetic acid, for example, that is CH3COOH. This is the formula for acetic acid. And when we are dissolving this in water, for example, we are dissolving this in water, what we will get? We will get two ions. One is positive, another one will be negative. That is, we will get CH3COO minus, and we will get H positive ion. In the definition already we have seen, acid dissociate to form H plus ion, and another one will be negative ion. So this is how it is happening. But this, all the molecules, whatever number of molecules are of CH3COOH, all those molecules will not dissociate, or they will not form ions. For example, if we are taking 100 molecules, just for an example only, if we are taking 100 molecules of acetic acid, then we can say around 10 molecules, 10 to 12 molecules are converting into ions. The remaining will, what about the remaining? The remaining will not form any ions. That is, they will remain as molecules only. So in simple language, we can also say, in other words, we can say the weak acid give us two things. When they are dissolved in water, we will get two things. One will be what? One will be ions. Sometimes some number of ions will be found. The remaining one will be molecule. Some ions, only few ions will be found, the remaining will be molecule. So acids, that is weak acid, give us ion as well as molecule when they are dissolved in water. On the other side, the strong ones, the strong acids are the ones which are inorganic acids. For example, HCl, if I take 100 molecules, they are also just an example of number of molecules. This is to make us clear. So if we are taking 100 molecules and we are putting this HCl in water, 100 molecules of HCl are dissolved in water, then what will happen? All the molecules, each and every molecule will break down and dissociate into positive and negative ions. All the molecules will will convert or dissociate into ions. So it must be clear now, the organic acids are the weak acid. Why they are weak acid? Because they do not ionize completely. They ionize, but it is partial ionization. Some of the molecules convert into ions, rest of the molecules remain as molecules only. So they will contain ions as well as molecules. Both will be present. This question may be asked, that is, organic acids dissociate into dash and dash. Then answer you will write ions and molecules. Similarly, they can ask the inorganic acids dissociate into, then answer you will write ions only. No molecules are remaining. If we are taking different molecules of HCl, all the molecules will convert into ions. Not only HCl, any of the inorganic acid, that is for example only I have used. So these are all strong acid. Why so? Because they ionize completely in solution. Because complete ionization is there, then what will happen? More number of H plus will be there. More number of H plus leads to what? It will lead to H3O positive. That means we will get more hydronium ions. So that is why it is written in the book, it will produce a high concentration of hydronium ions. So that is weak acids, strong acids. Now in these weak acids and the strong acids, we have an exception here. That is a special case here. That is carbonic acid. This separately you have to learn. Carbonic acid is the only inorganic acid which is a weak acid. All the inorganic acids are strong acids, but carbonic acid is only an exception. It is a weak mineral acid. It will form both ions as well as molecules. One more thing you have to remember here, in the organic acids, these are from the sources. One more thing that I missed here, they also contain carbon atom along with hydrogen atom. All the organic acids, you can see in the chemical formula there will be carbon as well as hydrogen atom present in these acids. All will be having carbon atom as well as the hydrogen atom. Now among the inorganic acids, also based on the element, we are classifying or giving some categories. Special names are given to these acids. First is oxyacids. Oxyacids are what? These are the acids. These are all inorganic only. These are the acids which contain oxygen, hydrogen, and one more element. Oxygen is there, hydrogen is there, and any other element is there. That element is generally a non-metal. That is a non-metal element. Generally a non-metal element is there. For example, you can see here nitric acid. Nitric acid is containing hydrogen, oxygen is there, and another element, that is nitrogen, is there. So that is why this is an example of what? This is an example of oxy acids. Similarly, we can say sulfuric acid. Sulfuric acid formula is H2SO4. So H2, that is hydrogen. Another element, that is a non-metal, sulfur is there, and oxygen is also there. So that is why this is also what? This is also an example of oxy acids. Similarly, one more category we have, that is called as hydracids. What is the hydracid? They are containing one hydrogen atom and another one will be a non-metal. Oxygen is not here. That example you can see HCl. HCl, hydrogen is there and Cl is a non-metal element. Similarly, HBr, hydrogen bromide, that is hydrogen is there and bromine is a non-metal. So these are all hydracids. Oxy acids, hydracid. These are all subcategories of the inorganic acids. After this classification of acids based on the types depending on the source of the acid, organic and inorganic, the second category of classification is depending on the basicity. What is the basicity now? First we will learn the topic of basicity, then we will do the classification. The basicity is what? It is the number of hydronium ions, H3O plus ion, that can be produced by one molecule of any acid. We are taking any molecule of acid, we have put that in water. What we will get? We will get ions. Ions, which ion? That is H3O plus ion. But how many ions are produced? Number of ions. That number of ions is deciding factor here. So whatever number of ions are produced, whenever any acid is dissolved in water, some ions will be produced. Those number of H3O plus ions which are produced, that will decide the basicity. If one hydronium ion is produced, then it is called as monobasic acid. Here you can see here, monobasic acid are what? Which on those acids which on ionization produce only one hydronium ion per molecule. Means one molecule of acid will give one hydronium ion. We can take one example for the monobasic acid. For example, we can take HNO3. This is a monobasic acid. So now if it is dissolved in water, what we will get? We will get H plus and NO3 minus. Now this H plus will dissolve in water and what we will get? Ultimately we will get H3O positive. H3O positive. So now one molecule of nitric acid produces one hydronium ion. Because of this it is called a monobasic acid. Similarly, many more are there. HBr, HNO3 we have already seen, HiCOO, CH3COOH. All these are monobasic acids. Now this CH3COOH is an exception. We will see it just now after covering all three categories. The next one is dibasic acid. The dibasic acids are the one which produce two hydronium ion. One molecule of acid dissolved in water and it will give us two hydronium ion. For example, we can see that is sulfuric acid. It will give us two hydronium ion. So that is why it is called a dibasic acid. It will give us two hydronium ions. That is why. How it is giving? You can see here the steps are given here. So you can see here these dibasic acids are they will ionize in two steps. First, this H2SO4 dissociate. It breaks down into two parts. One is HSO4 minus. Actually, what is happening? H2SO4 is breaking into two parts. One part become H plus. Now it's out of this H2 only one H is removed. One hydrogen atom is removed. That is forming H plus. The remaining part will be HSO4 minus. Again this HSO4 will again ionize. In the second step, this HSO4 now it will also break into two parts. Out of this hydrogen will again break out there and it will give us H plus, and the remaining part that will be sulfate SO4 2 minus. So this is how it is happening in two steps. You try to see in the book. I am facing a shortage of the board here. So H2SO4 dissociates or it ionizes into two different ions, but this ionization takes place in two steps, and in both the steps you can see one time both total two hydronium ions are produced. So one molecule of acid is giving us two hydronium ions. That is why this acid is a dibasic acid. The second one you can also see H2CO3. Here also one molecule of acid, only one acid molecule is there, but in these two steps we are getting total two hydronium ion. That is why it is a dibasic acids. So this is a example, different examples you have seen. Here also an exception is given in this box. We will come back soon. First we will see here the third category, that is tribasic acids. The tribasic acid, from the name itself it is clear, one acid molecule will produce three hydronium ions. Example, you can see H3PO4. H3PO4, it is a tribasic acid because it is producing 3 hydronium ions per molecule of the acid. Now because 3 is the basicity here, or it is a tribasic acid, so here you can see it is happening in 3 steps. This H3PO4 first dissociate into 2 parts. One part is actually becoming what? One part is giving H plus. Now out of this total 3 hydrogen, only 1 hydrogen is removed in one step. So remaining will be 2. 2 still remain there. So that is how it is happening. Again, this 2 will break down in the second step and the third step. One by one hydrogen atom is removed and forms a H plus ion. This is how it is happening in the tribasic acids. Now you may be thinking that whatever number is written here, let us have a look. I will write some examples here. HCl, it is having basicity 1. Another one H2SO4, it is having basicity 2. Another one H3 H3PO4, for example, it is having basicity 3. HCl is a monobasic, H2SO4 is dibasic, H3PO4 is tribasic. Now don't confuse here with the number of hydrogen. You may assume that whatever number of hydrogen is there, you can simply write this 1, 2 and 3 and it is very simple, no need to remember anything. But there are certain exceptions. This is not based on this number of hydrogen atom. You have to be careful. Don't be confused by this. So what actually it is? Let us have a look at the definition. They are not asking the number of hydrogen atom. They are asking the number of hydronium ions, and the number of hydronium ions that are producing depends on the bonding, the pattern of bonding. Now what I said to take a pause here. Let us have a look on this H3PO3. This is a special case here. Now H3PO3, earlier we have seen H3PO4, it is tribasic. H3PO4 is tribasic, but on the other side H3PO3, sorry, here H3PO3 is dibasic. Why is it so? You may see here both the things are having 3 atoms of hydrogen. Still one is tribasic, one is dibasic. The reason being the pattern of bonding. Now you see the structure here of this is the structure of H3PO3. This is here phosphorus in center, and you can observe here 2 atoms are arranged. They are bonded with OH. One hydrogen is directly attached to phosphorus. So this basicity depends on the number of hydrogen atom which are attached to the oxygen. How many hydrogen are attached to oxygen directly here? Only 2 are there. The first one here, the second one here. The third hydrogen is not attached or not bonded to any oxygen atom, because the third hydrogen, this number 3 hydrogen, is not attached to oxygen atom. It will not be counted for basicity. Only 2 hydrogens are connected to to oxygen bond. That is why the basicity for H3PO3 is 2. That is why it is dibasic in nature. The reason also is given there. The hydrogen atoms must be attached to oxygen atom. Only these are replaceable. They can only leave here. Other atoms which are directly attached to the central atom, like here phosphorus is attached to hydrogen, it cannot be replaced. It will not leave the molecule. Similarly, in the case of CH3COOH, that is acetic acid or vinegar, here also the bonding pattern is as such. Only one hydrogen atom will leave. You can see here total 4 hydrogen are there. You can see in the formula here H3 and 1 H here. Total 4 hydrogen are there. By assuming the number of hydrogen, you will say the basicity is 4, but that is not possible. Sorry. Here the structure is how the carbon atom is bonded to 3 hydrogen atom. These hydrogen atoms are directly bonded to carbon atom. They are not bonded to oxygen atom, and because these are not bonded to oxygen atom, they will not participate in any kind of chemical bond. This is the full bonding pattern I have made for you. This you will learn in this class 10 only, in the last chapter, the organic chemistry. This structure will come here. So now the hydrogen number 1, 2, 3, 4. 4 hydrogens are there. The hydrogen number 1, 2 and 3, they are not bonded to oxygen, so they all will not be a part of basicity. They will not be counted for basicity. Basicity only depends in this case on this particular hydrogen atom, which I have numbered 4 here, because this particular hydrogen atom is bonded with oxygen atom. So I hope it should be clear now. whatever number of atoms of hydrogen are bonded with oxygen are counted in regard to basicity. So that is all. The three types of basicity we have seen: monobasic, dibasic and tribasic. What is basicity? It is the number of hydronium ion produced by one molecule of acid when that acid is dissolved in water. Here a special case is given for the basicity. You can remember the name, the silicic acid, H4SiO4. None of the hydrogen is attached to oxygen, so the basicity is 4 here. Just a special case here. Now apart from this, the classification we have seen, first was the acid are classified into organic acids, inorganic acid. Second we have seen based on the basicity, monobasic, dibasic and tribasic. The third and the last one is now based on the concentration. The concentration classifies the acid into two parts. One is called as concentrated acid, the second one is called as the dilute acid. So first we will have a look what is concentration. Concentration is actually a simple term. It means the amount of acid, how much acid is present in a definite amount of aqueous solution. If we prepare any solution, aqueous solution, or we dissolve any acid in water, then in that solution how much acid is there, that defines the concentration. If more acid is there, then it is concentrated acid. If more water is there compared to the acid, then it will be dilute. That is a very simple definition. You can see here the definition is pretty much simple. Very small amount of water is there or no water at all is there, then it is concentrated acids. Another side we can say if acid is much more than its own mass, that is far more amount of water is there, then it will be dilute acids. So this is a very simple definition or classification of acids, concentrated as well as the dilute acids. Now here the concentration, and in this category of concentration you don't have to confuse with another term that is called as strength of acid. Strength of acid is something else. Strength defines something else. What is defines is it is based on the number of the concentration of hydronium ions. We have just now learned about the strong acids and weak acids. There this strong acid and weak acid is actually the strength of acid, but concentration is different things. Concentration is relating to the amount of water only, how much water is there. More water, then it is dilute acid. Less water, then it is concentrated acid. But strength of the acid is actually what? It is the number of or the measurement of the how much hydronium ions are produced in aqueous solution. If we dissolve any acid in water, how many hydronium ions will be produced? If more ions will be produced, then it is a strong acid. If less ions will be produced, then it is weak acid. Here a relationship is given, that is degree of ionization. This strength of acid depends on this degree of ionization, and the degree of ionization is denoted by the symbol that is called as alpha. That is degree of ionization, how much ionization will take place. So that we can calculate by this formula that is given: number of acid molecules ionized, how many molecules are converting into ions. Molecules of what? Acid. Acid we are dissolving in water, so how many molecules of acid have actually converted into ion, that we are writing in the first part. Upon the below there in this lower part we will write the total number of molecules, how many molecules actually we have added, and it is multiplied by 100. That will give us the degree of ionization. Now this is coming in percentage. If the percentage comes more than 30%, then it is called as strong acid. Otherwise, if it is coming less than 30%, then it is a weak acid. So just already we have seen weak acid are what? That are organic ones. Strong acid are what? Those are the mineral acid like HCl, H2SO4 and so on. That is all for the classification of acids. We have seen the different types of acids. The next topic now, the preparation of acids and their properties, that we will be covering in the next video. Here we will take a pause in this chapter. So today we have covered the introduction of acids, what are acids we have seen, and the different types of acids or categories of acids. That's all for the day. Thank you.